Hello, everyone. So, if you watched the previous video that I recorded, if you, are the kind of person who looks at the timestamps and everything, you'll notice that I just put out a video on nested for loops. And in that video, I referenced the previous video I recorded on just regular for loops, ones that aren't nested inside of each other. However, for the life of me, I cannot find where that video went. So I'm just redoing it essentially, and I'll have that up here for everyone to see. So if you're the kind of person who loves to spot out continuity errors in YouTube videos with very little views, congratulations, I beat you to this one. All right, so let's talk about a for loop. So a for loop is a very powerful tool that you can make. I like to think of them as kind of like little robots that do a task over and over and over again whenever you tell them to do it. So you can create very powerful things in your code without, taking and typing a lot of stuff over and over again. Let's do a little example. I'm going to go into my draw function right here, and I'm going to say, I'm gonna make a tree really fast. So let's say triangle. I'm gonna put this at width divided by 2. Oop, not comma 2. Divided by 2, 0. Let's see. Width and height divided by 2, and 0 and height divided by 2. I'll make this 255, 0. Make that green. All right. Boom. And let's add a trunk to this. Rect. Let's say 250. Let's make this. I'm thinking now. 200. 175, comma, height divided by 2 will be 200, and I'll make this 50 by 200. And let's fill. I don't know the RGB for brown offhand, so I'll make this brown. Alright, let's see if this works out how I thought. Boom, look, I made a tree. So there's my wonderful tree. You've never seen a better tree. I'm sure this is obviously the best art ever in the world. So good, in fact, I want to make multiple trees over and over and over again. So I'm going to copy this and try to do this here, and I'll tell you what, I'll go in and I'll separate these a little bit, just so we can tell them apart. And let's say I wanted to, again, I'll use this in a very quick way. Translate, and I'll say 100, negative 100. Translate, I'll move this one from that point. I'll move this negative 200, 100. Let's see, and then the last one, I'll translate this, I don't know, negative 100, 100. Oops. Here we are. Let's see, so now we've got, boom, multiple trees all over the place. It's a wonderful forest. But let's look at this just a little bit and kind of break it down. What we've ultimately got is 4, albeit very large, overlapping trees, very basic trees in our code here. And they're like that. That's all right. That's cool. But, 4 basic trees, but this is taking up about 20 lines of code just for these 4 trees. This is not super economic use of our code. Again, anyone looking at this is going to scroll through all of these things. And why are we verifying Lightroom Classic right now? I don't care. So to get for trying to update apps in the background while I'm recording a video. that I wasn't planning on recording. So anyways, um, we've got this here. We've got basically a large amount of space for a very little amount of things on the screen here. And so whoever's looking at this code is going to sift through all of this over and over again, trying to find what it is they want to find. But there is a better way. And that is where the idea of a for loop can come into play, at least in terms of working with graphics. They have plenty of other uses, and I'll go through one or two of them in the context of this video. But just so you know, there are many more uses other than the ones I will show right here. All right. So in fact, while I'm doing that, I'll mention that in the description of this video will be a link to this exact code. So if you wanted to pull this up on your own, explore it a little bit, figure out other potential uses for loops, maybe you watched the nested for loop video as well, you can see what happens, what you can achieve. Really, the possibilities are really limitless. All right, so if I run this again, we just have our original tree. It is what it is right there. All right, so that's not terrible. Let's make a for loop. So let's make one. I'll put it in. I'll do this one first in mouse press, just so we can see how the for loop works before we start trying to do things with it in graphics. So I'll be making a few of them in this video. All right. So to make a for loop, you first have to type out for, and that's where the name came from. It gets a some parentheses and some curly brackets right there. It's formatted fairly similar to a conditional statement. It's got, again, some conditions that you put in these parentheses, and then the resulting code that you want executed happens in the braces. What's different from a conditional statement is instead of it just being a simple is A compared to B true, yes or no, we have a few extra things to put in, a few extra commands. So the very first thing you have to do is make a local variable. And assign that a value to start with, right? That's the first thing you have to do. This variable is going to be used in order to track the progression of our for loop. One thing to note is that these variables are never referred to outside of this loop. They are localized to the loop itself. So it's very common just to give these quick little one-letter names. It's very common to start. You'll see a lot of them that start with I for index. Working through arrays and things like that's where it comes from. But really, it could be anything. You could give it a whole name, like another variable outside of your for loops if you wanted to. But it's very common just to make it a quick single letter, saves time typing. Because again, really the variable itself isn't what you're going for with the for loop, and it's never being referred to outside of it, so the name doesn't particularly matter. All right, so you'll notice I put a semicolon here instead of a comma, like I've separated all the other elements in parentheses in the code. These are kind of all separate little commands to give it, so we're separating these with semicolons, not commas. If you do commas, you're going to get an error. Your for loop will not work. The next thing we're going to do is give the for loop essentially how many times we want to run the loop. And it's while not strictly required, it is very common and just a good practice to make it all related back to this variable that we made in the first command. So for as long as I is some value, I'll say less than 10. All right, we'll do that. For as long as I is less than 10, we're going to be running this for loop. And that's all we type there, I less than 10, semicolon. Now you'll notice, well, I is 0 at the moment, but we want it to run for as long as it's less than 10. Well, that's going to be forever unless we affect this for loop in some way. So the very last thing we put here is some affectation of the variable. It's essentially what you want the for loop to do at the end of the loop. A very common thing is just I++. We're going to increase our variable by 1. So let's break this down just a little bit. Um, when we start and have our for loop run, we're going to make a variable at the beginning of the for loop routine, and then we're going to check and see this comparison. Is it true? In this case, is I less than 10? Well, I was initialized at 0, so yes, that's true. So then we're going to execute all of the code in the braces, and at the end of that, we're then going to perform this last command here. We're going to increase I by 1. So then we're going to check again, is I less than 10? Well, we increased I by 1 in the last loop, so it's now equal to 1. 1 is less than 10, so yes, we're going to execute all of the code in the braces, and at the end, increase I by 1. This is going to go again and again until eventually I is going to equal 10. Well, 10 is not less than 10. 10 is equal to 10. So this middle statement is going to be false. As soon as that's false, the for loop is going to stop running, and the computer will get on to its next thing. All right. So to see that in action, let's say console.log in our results, and we'll say we're just going to log the value of I. I've put this inside of mouse press, so when I run the code here, every time I click the mouse, we'll get in our console the value of I. So I'm going to bring this up so we can see it, and I'm going to click the mouse on the canvas. Boom. So we get all of these here. We get 10 instances, 0 through 9. Again, it's not including 10 because 10 is not less than 10. If you want it to include that extra iteration, you can just say less than or equal to 10, because 10 is less than or equal to 10. That just depends on the context of your loop and how you're setting it up, just how many times you want it to run. So you got that there. Technically, these elements here don't have to be related to each other, related to I at all. It could go based on other items in your code. However, with that point, you do run the risk of creating a for loop that will essentially crash your computer. So I mentioned that this is going to run for a while, and then it's going to stop, and the computer is going to move on to its next task. Well, if you've accidentally created a for loop that will never stop, that essentially locks up your computer, is going to be forever executing this over and over and over and over again and never be able to stop. And the only way to fix that, in this case, would be to close out your web browser here that's running the code. You might even have to completely quit the browser or potentially restart the computer. It'll vary from computer to computer, and if you're using a web editor or some other code editor that's not online, your results could vary, but essentially you'll have to completely get out of the process of this for loop manually. What that might look like, if I had something like this, this would be a kind of incorrect for loop. This one wouldn't lock up our computer per se. It would essentially just never start. So to break this down step by step, we're going to make I and assign it 0, and then we're going to check and see if I is greater than 10. Well, 0 is not greater than 10, so that's false. The computer is just not going to run the for loop ever, and that's it. So you'll never see those results. Let's put that back how it was, but let's make this so now we're subtracting 1 from I each time. Well, we start at 0, that's less than 10, so we're going to run the code. Then we go to -1, well, that's less than 10, so we run the code. And it's going to go on, it's going to go to 10, run the code. It's going to go to -11. Well, -11 is less than 10. It's going to run the code. And again and again and again. It's going to forever move away and always be less than 10. So it's going to get in this infinite cycle over and over again. And that's how your computer can get locked up from doing all of this. So that is a potential hazard in working with for loops and not being meticulous with creating these elements. That's why I always recommend, unless you need it for a very specific reason to not be, having them all be related, using the same variable, and just have a real direct processing of that variable so you don't accidentally break something. One way to help avoid this incidentally is turning off that auto refresh button in the P5 editor. I just turn it on and off. I always, when I remember, turn it off while working with for loops. Because what auto refresh will do is it will go in, and every time you type in your code, once you stop typing, it will try to rerun your code to be up to date with the most recent changes. It's a handy feature most of the time. Saves a lot of time. However, if you've accidentally mistyped your for loop here, or you started typing it out and haven't finished it, the code will try to run it automatically. And if something is wrong, it could lock up your code with the for loop. It will just automatically happen, and you will have to close out. You could potentially lose, hours worth of work depending on the last time that your project saved. Also, remember to save your sketch very frequently. And you don't want that. So I always turn it off. The only thing is you then have to just remember to manually go up and refresh your code every time you want to see any changes. Not the end of the world. It's just an extra step. It's not going to automatically happen. So just one little thing to remember as we're going about doing that. All right, so I've shown off that we've essentially run this. Now every time I click the mouse, we get the numbers 0 through 9 put in the console just like that. Each one of those numbers, again, is a separate iteration of our for loop. And we just have that going on right there. If we wanted to see that a little more clearly, I can say, let's go on, let counter equal 0. And we'll say console.log times for loop has run. Let's say, oop, that's wrong. Colon space there plus counter plus counter plus inner iterations colon space colon space there, and I want one iteration there plus I. All right, and then just one kind of final thing here. All right, so let's do this. I'm kind of doing this on the fly. Rerun that. Boom. So now we get this. Actually, I'll start that at 1. Boom. So now we get this. I click it, run the code. So we've run this for loop. I guess I'll say time for loop has been triggered. And I'll change this a little bit to times for has looped. All right, there we are. That'll be a little more clear, I think. So we've triggered this once, and it's going to repeat itself over again and again. And we see that it goes again. Click it again. Where did that go to? Oh. It's because that's local and it went away after that reset. Boom. All right. Now this example will work that I made on the fly. So starts at 1. Cool. We did the thing. We see that it's been triggered once and it's running all those 9 times. We click it again. Now we've triggered it twice and it's running all of those times 0 through 9. Click it again. It's now happened 3 times. Goes 0 through 9 each of that times. Every time I click the mouse, I've only clicked the mouse 4 times, but every time I click it, that loop is running as fast as it can go, doing its code. Every time it makes a new version of I, checks it, runs the loop, goes again and again and again. So we have that there. All right. So cool. I'll leave this here for now, because again, this is only affecting the console, so we don't even have to worry about that. Let's make one that'll function in with our shapes on the screen. So I'm going to make my tree just a tad smaller. Let's see. Just 10 smaller. I'll make this instead of width, I'll make this 300, and I'll make this 100. So this should shrink it a bit, and instead of 0, I'll make this 100 as well. All right, much smaller tree, a little bit easier to work with. We're going to encapsulate this inside of a for loop. All right, but before we get there, I'm going to do kind of an intermediate step so we can see the idea, and then we'll apply it to our trees here. All right, so I'm going to say for there, and for this one I'll say let I equal 0. I is less than I'll say less than 10. Forgot my I plus plus. All right, so I'm just gonna real quickly, I'm gonna do a row of circles along the bottom of the screen here. So let's say ellipse. All right, so let's say that for whatever reason you wanted to make a repeating pattern. All right, well, this is a great way to use a for loop, because if you've noticed, whenever I press the mouse, you get essentially the same thing over and over again with slight changes to it. It's repeating this code multiple times. It's looping the code. So let's use this for our ellipses here. I'm gonna say fill. I don't know. These will be pink. All right. So these ellipses. So I want this to be a horizontal row. So for the X position, I'm going to say I times 20. And I'll make this 180. And then I'll just make these 10 by 10. All right. So I'll run this, and then I'll break this down. We got that there. Oops, I'm sorry, that should be 380. There we go. So we can do this, and I'll make this 20. And I'll add one more to the end. There we are. Now it's nice and symmetrical. That was going to bug me. So let's break this down. So in the for loop, we are setting the fill to pink, and then we are drawing this circle. However, I'm referring to this variable I while drawing the circle. Keep in mind that we are drawing this a total of 21 different times, because again, we're starting at 0, and we're going all the way until I equals 20. Every time we're doing that, we're setting the fill, drawing the ellipse. If I was just to go in and say, make this a number like we normally would have, 50, and run it, you're only going to see one, because it's drawing essentially the same circle on top of itself 21 times. And if you have a nice high-def screen, you'll notice that it looks a little fuzzy almost, because again, we have all of these kind of on top of each other, almost like you get a little flip book. It's the same sheet on top of each other a bunch of times. So we can spread these all out. And we can do this locally, again, by referring to the I variables. So I had I times 20. All right. And by doing it this way, we start off in our very first iteration, I is equal to 0. So we'll draw the ellipse with 0 times 20 is 0. In the next iteration, we've now increased this to 1. Well, 1 times 20 is 20, so we're going to draw this circle at with x equaling 20. The next time we get 2. 2 times 20 is 40. It's there, and so on and so on and so on until the loop stops. And that's it. So we get this repeating pattern over and over again based off of our manipulation of I. And I find that going with the multiplication right here is a great way when using the I++ method, just increasing it by 1. You get this nice scaled repetition of everything right here. There's another way to go about this in building the for loop as well, And I'll do that just real quick. I'll put a row of rectangles up top doing it this way. So if we made 4, and I'll say, that's not what I wanted to do. All right, so I'll say 4, and then here I'll say let I be assigned. I'm going to change this up, so I'll say let I be assigned 50. I'm going to run this for as long as I is less than the height, and then we're going to say I gets increased by 50. All right, we get that there. So I'm going to say fill. I'll make this orange. We don't have time to figure out RGB colors at the moment. So I'll do erect. All right. And what we're going to do is instead, I'll make this, 25. But I'm going to say I there. I'll make this 25 by 25. Real basic numbers. So I'll run this. So we get this. In fact, if I wanted to change that to 25, make this, I'll stop it at 300. So see, that was a case where the for loop never started because 525 was automatically bigger than 300. This is what I was going for right there. So this is set up the same process slightly differently. Instead of just increasing these values by 1 and manipulating it in the results, you could also go about and manipulate things in the for loop itself. So there's no rule that says you have to start it at 0 and do all this scaling of it in your results. If you're doing multiple things in your single for loop, I definitely recommend doing it like this first one here of scaling it individually in the results. But if you're only doing one thing, you could go about it this way. So we're starting I is equal to 25. I'm going to draw this here. So we get our rectangle. It's orange. We get it at 25, 25. We draw it. The next time we've only using just the base I. The next time we've increased it by 50. So since we're using that to control the vertical aspect of it, it moves down by 50. We get the same rectangle, and the same thing again and again and again. There's 2 different ways to go about doing this. Again, if you're going to be doing multiple things in your for loop, so say I wanted to draw an additional shape here of, ellipse, I times 30. I'll put this at 30, and I'll make them 30 wide. Picking real roundabout numbers here, and boom, do it like that. We're making both of these in the same for loop, so we're referring to the same values. You could, again, tweak it all based off of the number of iterations in your for loop I have here on line 10, but we're scaling them in different ways to use the values in different ways. If I wanted to go in and say, I times 2 here as well, we can see that, cool, they're also getting bigger. Is another thing there, but it's the same value. It's the same for loop. Since this one here, our squares, it's the only thing here, we can just make our rectangle function be real simple and affect everything here. And if we wanted to have everything with the same manipulation of our for loop, you could add stuff. I just recommend that if you're going to be doing multiple things or some kind of complex things, set it up like this, starting it at 0, moving forward in a set way, and doing all of your scaling in your results. That's my recommendation. Okay, last little bit, I mentioned doing shapes with the tree here, setting up multiple ones here. So we'll just wrap this up, say 4, build this, around the tree we already have. Set that there. Tidy that up just a little bit. All right, so let's go say I gets assigned 0. Let's make a total of 5 trees. All right, nothing too crazy. So we'll say I less than 5, I plus plus. All right, we've got that there. If we were to run this just as it is, again, you would get the same tree exactly on top of itself. So we can essentially affect the multiple trees by referring back to our I variable. Keep in mind it is okay that all of these are labeled as I because the I only exists within each for loop. So as soon as this first one is done, it goes away and I never exists again. Then it makes a new version of I on line 16 and again on line 21. And this happens every time the draw loop repeats itself. All right, so let's just throw some I into here. So I'll start with the rectangle because that'll be easy. If I want a repeating pattern, I'll say, I times 4, I times 2. There we are. If I were to run this, we get our trunks again and again. It's not going to be the best because, again, these are very small numbers. And again, so 4, it goes 0, 4, 8, and so on. So if I want to increase that by 40, 200, maybe a little less than 200. But we can get that. So you can kind of play around with this a little bit, get the right aspect. So I'll say 100, and I'll make this 80. Boom. All right, I'll make this actually 280. I'll keep that at 80, but I'm just going to also increase this by 100, so it just shifts everything down. So that way, we get the top of the tree as well. In fact, if I wanted to shift all of this here, I could say plus 100 as well. So that way it just shifts it all over. Actually, let's make that 50 so we don't lose that last one. There we go. All right, now let's work with the tree. That's more typing than I want to do. Let's make this an ellipse. All right, it's going to be a circular tree instead of a pine tree. So again, same kind of thing. We'll go using I for both the X and the Y. And we'll go in and I'll make this a 100 by 100 circle. I'll make it an oval, 150. At the moment, they're all more or less going to be on top of each other. So we need to affect both of these eyes in some way. Let's just start with the exact same thing we have here. Just going to copy that, paste it, make that a little tidier to look at, run it. So now we've almost got it. We can just kind of slightly affect these by moving them over and down. So let's say instead of by 50, we'll go by 70. It'll probably be 80. The math for this is actually pretty simple. I just didn't remember what my initial shapes were, so I can't just do it offhand without looking. All right, 75. Now let's move this down, and we'll change this to 125. 25. Oop, not times 125. Yeah. Times 80 plus 125. There we go. All right, let's make that an even 100. And then let's go in and just change the order real quick, because now they're overlapping a little bit. So now I'll have the tree on top, and boom, our wonderful trees. If we wanted to make the trunks a little bit taller, I guess we could go to like 90. Actually, we know we'd want to go I'm tired of working at the details. I've had to do a few of these in a row. that I wasn't planning to do. Boom, our wonderful tree is using nothing but for loops. All right, so got this up and going. I hope this kind of has given you some, insight into how to create a for loop. Again, you just have your, you say for, and then in your parentheses, you create a variable that's going to be used for monitoring the for loop. You're going to have a number of iterations. Again, this is going to run until, in this case, I is no longer less than or equal to 20. So you make a true statement that will eventually be false. And the way we make this be false is by affecting that statement, so that same variable. So at the end of every loop, you're going to increase I by 1 in this case. There's no hard rule that it has to be that way. Again, I illustrated that with our rectangles here. But it's very common to see that, especially when you have multiple things happening. You can affect all of these, this I in different ways. So we have that there. And then, again, I've also got, if you explore in this code, just breaking down that I'm triggering this every time. Every time I trigger this, we get all of these iterations over and over again. So yeah, I'll have a link to this if you want to explore a little bit how the code is set up, things like that. You can play around. I'll have this in the description of the video. Remember to save all of this, have your auto refresh ticked to off just to be safe. And that's all for this video. So if anyone has any questions about this, thanks to some new interesting ways to use for loops, I'd love to see that. Feel free to put that in the comments down below. And